everyone, welcome to my channel. And today's topic about the enzymes. Obviously this is the elaborate topic, and today's video, before that I have started this enzyme total topic. First, in my previous video I discussed about the microequation equation, and today I will explain about the double reciprocal plot. Okay. And first you check out the my previous video about the microequation equation, and then you follow this one. Here I describe about the double reciprocal plot. Okay. So what is the microequation equation? That is the V equals to Vmax substrate concentration divided by Km plus substrate concentration, and this is the microequation equation. Okay, they have actually established this equation. Clear? And this is the double reciprocal plot, and this is another type of topic, because here we just learn about the Vmax and Km determined by varying substrate concentration. Okay, maximum Vmax and Km. What is the calculation, or what is the result of Vmax and Km, and what kind of graph we can see here? This is the double reciprocal plot, and here the actually substrate concentration that varied here. So first this is the actual equation of the total relation of the Vmax, V and the Km and the substrate concentration. And here before going to double reciprocal plot, first we describe about the we learn about this graph here. Here you can see this side. This is the 1 by substrate concentration. This shows, and actually we plot the substrate concentration reversibly, or reciprocal. Sorry, reversibly, not reciprocally. And here this side we plot the V value reciprocal. That means 1 by V here and 1 by S here. And so you can see this is the y-intercept that shows the 1 by Vmax, and this is the x-intercept in first slide here. Okay. So this is the x-intercept, and here the minus 1 by Km is the value of the x. Okay, and this is negative obviously, and you can see here the line is the straight line. Generally in that situation we generally see the hyperbolic graph or the curve, and but here we see here that is a straight line. And how this relation is plotted in the double reciprocal plot, you just see that this is the actually reaction. V equals to Vmax by S and Km plus S. Okay, I just reciprocally I interchange this one like that. 1 by V equals to Km plus S and Vmax by S. I just reverse this side. That means 1 by V. V is, I just write here, V is in the lower portion and 1 is in the upper side, and here the Km plus S that I write here in the upper side, and Vmax S that I write here in the lower side. Just I reciprocally write down here. Okay. So what happened here? You just this one Km plus S by Vmax concentration of S. I just separate this one in that way. Okay, Km by Vmax S plus S by Vmax S. Okay, Vmax just Km is separated from the substrate concentration by Vmax S in such a way. Clear? Now you see here that S and S is cancelled here, so that means Km by Vmax S plus 1 by Vmax. Clear? That means S and S here cancelled. Now this is actually the equation we see here. This is the actually equation of the straight line. You can say y equals to ax plus b. You actually this is the straight line formula. That is the y equals to ax plus b. Now this is y, 1 by v, this is the y, and Km by Vmax S, this is the Ax, plus 1 by Vmax, this is the B. Okay, so now you see here, in case of y-intercept, there x is 0. So this equation is y equals to Ax plus B. So I just write here the value of x, that is 0 here. Okay, you see here. That means the y equals to B. Here y equals to B, and I just write here what is the value of the B. B is the value of the Vmax. Here next then y equals to B, and that is the value of 1 by Vmax. Sorry, one second. Okay, sorry for the disturbance. Actually, there is some noises, so that's why I stopped the video. So you see here the value of the x, that is 0. That means y equals to B. B is the value of 1 by Vmax. Next one, in case of second, where the x value is minus 1 by B, that means y is 0 here. Okay, there is a sorry for the disturbance. Actually, noise for noise I just stopped my video. Okay. So what I'm saying that in y-intercept, when I just put here, you see that when the value that remain in the y line, that means the x value is always 0. So here I just put the value of the x 0, and then we get the y equals to B, that is the 1 by Vmax. So here I put the 1 by Vmax. Clear? And next one, in the next x-intercept, when any value that remain in the x-intercept, that means the y value is there 0. So here x value is minus a by b, and that means minus 1 by Km. In that way, you will see the value of 1 by Vmax and value of 1 by minus Km, that is obviously negative, not be positive. This is the double reciprocal plot, and it is the another topic, that means totally another topic. This is not related to the Michaelis-Menten equation. Okay, so this is fully another topic, and that is related to when the substrate concentration vary, then how the Vmax and Km is determined. Clear? Now I describe about the significance of the Km and Vmax value. What is the significance of Km and the Vmax value? The significance, it is very easy. Significance of the Vmax and Km value. That means if you know this equation completely, with the helping of this equation, the velocity of enzyme action that can be easily calculated. Okay, this is the velocity of enzyme action, that means the V, it can be easily calculated. Second one, the Km value also be calculated easily. If this value is known and this value is known, obviously substrate concentration is known. That means the Km value is also be calculated. And the last one, the changes of the velocity of enzyme can be calculated also. How the velocity changes from one enzyme to another enzyme, by establishing this equation, we can identify the enzyme velocity, changing velocity. Okay, these are the significance of the Km and the Vmax value. Now we learned about the enzyme substrate concentration factors. What factors are very important for the reaction of the enzyme substrate complex? Okay, before going to discuss about the factors of enzyme and substrate reactions, first we discuss what is the Kcat, Km criterion. Kcat means the maximal catalytic rate. Maximal Kcat means that is the maximal catalytic rate. Okay, it is denoted by Kcat, and this is possible when the substrate is totally saturated. Okay, substrate is totally saturated. S by Km, substrate concentration by Km, that remain always 0.01 to 1.0. But when substrate concentration is less than the Km, then the enzymatic rate is much less. Clear? and less than the K3. K3 is what? K3 is the formation of the product rate. Okay, when the formation of product is formed from the ES complex, that is the rate is the K3. So what is we learned, what we just learned here, S is when less than Km, that means the enzymatic rate is much less than K3, and most active sites are unoccupied. In that situation, the active sites are unoccupied. Okay, and active sites are generally free at that situation. And what happened in that situation? V equals to K3 by Km, E concentration and the S substrate concentration. This will happen. Okay. And when the S is less than Km, another situation is seen, that is the free enzyme concentration is the ET, total enzyme concentration. Free enzyme concentration, that is equal to the total enzyme concentration. Okay, that means the active sites are generally free. Okay, and in that situation, what happened? The V equals to S K3 by Km into substrate concentration into ET. When we just write here replacing E, that is ET. That means totally free. All the enzymes are now free. Actually not occupied by the substrates, because substrate concentration is very less here. Clear? Now, the enzymatic velocity that depends on the value of K3 by Km and on the S. Clear? Enzymatic velocity actually depends on the substrate concentration and K3 by Km value. Okay, and this K3 by Km value depends on what? This depends on the K1, K2 and the K3. What is the K1? This is K1. What is the K1? K1 is the rate of formation of ES complex. K2 is the rate of dissociation of ES complex. And K3 is the formation of the product rate. Okay, and this Km, after substituting for Km, we get this equation that is K3 K1 by K2 plus K3, and that is always lesser than K1. Actually, K1 is very important, okay, because this K3 by Km value is set by actually the K1, that means the rate of the formation of the EX complex. So, the maximal catalytic rate, the Kcat, actually depends on the K1. Clear? This is the Kcat and Km criterion, and what happened in the situation, the maximal catalytic rate is created in what situation? This is explained here. Clear? So actually you learn about the Kcat by Km criterion, or the catalytic rate, how the catalytic rate is generally calculated or how it is recognized. So we just learned here. That means the actual value of the K1, K2 and K3 is very important. Here, okay. So this is my another video that is related to the enzyme kinetics, and you just follow this one and my previous video about the microenzyme equation. And if you like this video, then you can share and like and subscribe that. Okay. Thank you.